Welcome back to our channel. Machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically by feeding it tons of data. Here I have taken a data frame from Kaggle which has 12 features, and heart disease is the feature which we have to predict it using other 11 features. The values of these features are both numeric as well as non-numeric. The variables sex, chest pain type, resting ECG, exercise angina, ST underscore slope, they are non-numeric, are called as categorical variables. They belong to object data types. So with this data frame, we will proceed to implement the Python program to predict heart failure using gradient boosting algorithm. We will also be using get dummies method of pandas to convert our categorical variables into a dummy or indicator variables. If you have not subscribed to our channel, please subscribe and share with your friends. I have imported NumPy and Pandas package. We will read the database using read underscore CSV method from Pandas package. So I'm passing the path of this database which I have taken from the Kaggle. You have to pass the location of your file exactly to read CSV. So using info method, when we see the data frame, we could see there are 12 columns with index 0 to 11, and there are all non-none values. There are data types like integer, object and float. There is one float data type, 6 integer data type and 5 object types. The variables sex, chest pain type, resting ECG, exercise angina, ST underscore slope, these are 5 object types. They are non-numeric values. Now we will see what are the categorical values in the categorical variable, that is data type of object for sex column. For that I have used the value counts method, and we could see there are only two values, M and F, which stands for male and female. We will proceed to replace M and F, the categorical values of categorical variable sex, with 0 and 1 respectively. This can be done by using replace method and pass the dictionary with key and value M0 F1 by setting in place equal to true. Again, calling the info method, we could see that object values are reduced from 5 to 4 and integer is incremented from 6 to 7. This is because we have made the categorical variable sex to a numerical value integer data types. In total, there are 12 features. So now we will also see what are the categorical values for other 4 object data types in our data frame. As we remember, the other 4 are chest pain, resting BP, exercise angina and ST slope. We could see there are 4 categorical values: ASY, NAP, ATA, TA for chest pain type, normal, LVH, ST for resting ECG, N and Y, that is no or yes for exercise angina, flat, up, down, 3 categorical values for ST slope. So in total there are 12 categorical values coming under 4 categorical variables. For machine learning algorithms to use on the database should have only numerical input data. If we try to use string-based categorical data of the data frame, then the machine learning algorithm will throw an error. So it is necessary to convert categorical variables to numeric variable called as dummy or indicator variables. So first, before converting, we have to get those 4 categorical variables to a list. So I have a list called categorical column, cat column. For every I in a data type in the data frame of index, if that index is same as object type, the index is nothing but the column. As we know, there are 12 columns ranging from 0 to 11. If they match to the object, then we have to append to the cat column. Now on printing the cat column, as expected, we could see the 4 columns, namely chest pain type, resting ECG, exercise angina and ST underscore slope. These are of object data types in our data frame. They are also called as categorical variables as they are non-numeric variables. Now, after getting this categorical variable to a list, we should convert these categorical variables to indicator variable using getDummies method of pandas. The first argument is the data frame itself. The columns parameter specifies the columns that is to transform to the dummy variable. Here cat column list has the categorical variable names. So we using info, again we will see the characteristics of our data frame, because now we have converted the categorical variables to indicator variables. We could see that we got 20 columns. Originally there were 12 columns or the 12 variables. We got 20 because we have expanded chest pain type categorical variable to 4 dummy variables. The names are with the original categorical variable, that is chest pain type, then there is an underscore followed by the categorical variable like ASY. Similarly, ST underscore slope is the categorical variable and there is an underscore, then the down, flat, up are appended. So totally we got 12 categorical 12 columns. By default, get dummies used this drop first set to false. We will be using drop first to true. This causes get dummies to exclude the dummy variable for the first category of the variable, resulting in 16 columns, because the first category variable of chest pain type is dropped. This is because if all the existing dummy variables equal to 0, then we know that the value should be 1 for the remaining dummy variables. That way, in resting ECG, exercise angina and ST underscore slope, the first category value of the category variable is dropped, resulting in only 16 columns. So now we made the data frame ready by doing data analysis, and we have converted the categorical variable to dummy or indicator variable. We have also seen that all the values are non-null. That means there is no null values in our data frame. The subsequent step is to scale the database for important input variable, train the model and test it. At last, we have to calculate the accuracy of our model. So we are coming to scale the database for input variables. For that, we will use SCIKIT-Learn package and let us import standard scaler for scaling the data frame for pre-processing. Similarly, we will import train test split, which is needed to split the database for testing and training, and gradient boosting classifier is a supervised learning algorithm that is built by combining the decision trees with a technique called boosting. We have to do the scaling for important input variables to avoid the bias in making the model execution. When the values are of different ranges, scaling helps us to remove the bias. We will take three important input variables for this scaling factor. They are resting blood pressure, cholesterol, and maximum heart rate. As we saw in the database, these values are of different ranges, hence scaling becomes necessary. Let us use fit transform and pass these three columns. And let us create a new data frame called scaled underscore to underscore df using data frame method of pandas. Create the scaled values with columns named as resting BP underscore SC, cholesterol underscore SC, max HR underscore SC. So a new data frame scaled to DF is created with the scaled values and the corresponding column names are specified. Using the head method, let us see what this scaled to data frame has. On execution, at this step, we will confirm if the values are scaled in the specific range. We could see that the resting blood pressure, cholesterol, and maximum heart rate are scaled between -0 and 1 and -1. So they are in the common range, which removes the bias when predicting the heart disease. So now we will concatenate our scaled to data frame consisting of these three variables with our original data frame with axis set to 1, meaning the concatenation will be happening at column wise. We can drop the unscaled values, namely the resting BP, cholesterol, and max HR, which is contained in the list columns. So now again we will print our data frame using head method. We will see the characteristics. We could see that there are 16 columns which is formed by using get dummies, and now first three features are scaled one and other variables as originally formed using get dummies, which is used for converting the categorical variable into a dummy variable. So after creating the scaled data frame, now we have to proceed to train the model on the database and test it. For that, let us take the input value X, which consists of all features except heart disease. So using drop method for heart disease along axis equal to 1, X has all other features. Y, which is to be predicted, that's an output value, shall have only the column, namely heart disease. Using train test split method, let us have 25% of the data frame for testing and the remaining 75% for training the data set. So X-train, X-test, Y-train, Y-test are formed by splitting in the ratio of 25% for test size and 75% for training it. Random state is set to 42, which is used for initializing the internal random number generator for splitting the data into test and train indices. As we know, hard disk is a supervised model under classification, so we will use gradient boosting classifier. We have also imported the gradient boosting classifier already, hence using fit method let us pass the training data, that is X train and Y train, and predict Y predict using predict method. So this trains the model using gradient boosting classifier, which is a supervised learning algorithm that is built by combining decision trees with unique technique called boosting. On execution, our code is executed successfully. It is better if we see the accuracy of our gradient boosting classifier. Already we have imported accuracy score from SCIKIT-Learn metrics package. So by calling the method accuracy score, which takes the parameters Y test and Y predict, we get the accuracy score for gradient boosting classifier. Hence directly we can print the score. On execution, we are getting the accuracy score for uh, grading gradient boosting algorithm as 0.869, which is 87%, and this is a very good accuracy because the boosting algorithm combine multiple weak learners in a sequential manner, which initially proves and helps to reduce the high bias. So now we have created categorical variables using get dummies of pandas, which converted categorical variable into dummy indicator. Then we have scaled the important input variables to predict the hard disease using standard scalar. We have also trained and tested the model using gradient boosting classifier, which gives the accuracy rate of 87%. Hope you liked the video. Please subscribe to our channel and click the like and share with your friends.